Okay, so we want to continue on here and extend what we were talking about with triple integrals to different types of regions that we can try to integrate over. You might recall that when we did double integrals, we had like type 1 and type 2 regions, regions that were bounded by like a top function and a bottom, or a left and a right. Well, if I'm in 3 dimensions, you can start to imagine like you're trapped in some sort of a room. And every room has maybe like a floor and a ceiling, and maybe a side wall and another side wall, maybe a front, something in front of you, something back of you. And so these can kind of correspond to different kinds of regions. So here, a solid region E is said to be a type 1 region if it lies between the graphs of 2 continuous functions of x and y. So this is kind of, or a type 1 region kind of corresponds to Z being bounded. Like again, I have some function that is acting as a floor, and I have some other function that's acting as a ceiling. And again, these are landscapes, right, that are going to be kind of capping off this region. So we're going to be thinking about that. And intuitively, we could imagine defining like a type 2 region and a type 3 region as maybe ones with like side walls or front and back walls. Okay, that's kind of what the note down here talks about, and we'll deal with some of that stuff here in just a moment. This idea of D being a projection of E into the XY plane is a little bit complicated, but we can take this sentence here and read it all the way through. So we say that E is going to be a collection of all the points x comma y comma z such that my x and y's come out of that floor. There's got to be some boundary on the floor that I'm allowed to walk around in. Again, if I'm trapped in a room, I can't walk to any location. I can only walk to locations within the confines of those walls. And so that's kind of what this D is. It's what happens when I take this region E and I only restrict it to like looking at the floor. I'm trying to see what that looks like. And we'll see kind of how this works in some of the examples to come. Okay. We can go ahead here, though, and deal with a really nice theorem that extends, again, ideas from 4.2. If E is a type 1 region, then when I'm attempting to do a triple integral over E with my function, I can set that up as a double integral over D, thinking maybe like the floor again, like what's the region that I can work with? And then on the inside, I have this final integral. There's the third integral out of the triple. And notice that that's an integral that involves z. So what I'm going to have here are kind of like my functions that bound the floor and the ceiling. And those would be the innermost bounds. The outer bounds are going to be things with x's and y's, but notice I'm not specifying what order they have to come in. If it's a double integral at the edges, right, out here I have a double integral and the double integral differential at the back, those can be stressed in whatever, or expressed in whatever way that I prefer. And I can do something very analogous again for type 2 and type 3 regions, where again I'm maybe going to integrate by, instead of thinking about floor and ceiling, maybe I'm going to start with thinking about the wall in front of me and the wall in back of me first, or maybe the wall to the left and then to the right. Okay. So what we're going to try to do here is to think about a general strategy that we could start to come up with for setting up these triple integrals. Now, the strategy that I have above, down below, in the box has listed out a couple things. And very honestly, I'm not even going to read through it because the bolded all caps text is the #1 thing that we should be aware of. As it states here, the key to getting good at setting up triple for evaluation is understanding the geometry of the situation and the inequalities that are involved. So we're going to have to take a look at some examples to see how we can set up the geometry, how we can draw a picture, how do we understand the scenario that we're given. And then it might make sense to move through the steps that we have listed here. Again, I'm going to leave out these steps. Obviously, you can go through and read through them on your own, but we're going to go ahead and just see how these begin to apply as we take a look at example number 2.